Welcome back. Now we can do exercise 9.3. Find the sum to n terms of the sequence 8, 88, 888, 8888, etc. The sum to n terms. Okay. So we have to find Sn. The notation is Sn, sum to n terms of this particular sequence. So it is 8 plus. Sum means we have to add all these 888 plus 8888 plus etc. etc. n terms are there. Now, is it AP or GP? It is not AP since the difference is not same. It is not GP also. Why? 8 into 11 is 88, but 88 into 11 is not 888. So it is neither GP nor AP. So we can't use that two formulas directly. What we do here is we can convert this to GP. Okay. So for that, first we have to take 8 outside. So when we take 8 outside, the first term is 1. Then next is 11, 1, 1, 1 plus 1, 1, 1, 1 plus etc. like that. N terms. Okay. Up to n terms. Now, again this is not GP. It is not AP. It is not GP. So, to convert this bracket to GP, what we do is multiply and divide by 9. Okay, multiply and divide by 9. So, when we multiply this bracket by 9, first term is 9, 99, 999, 9000, okay, plus etc. Now, the next step is 8 by 9 into this 9 we can write as 10 minus 1. Okay. Then 99 is 10 square minus 1. Isn't it? 10 square is 100, 100 minus 1 is 99. Then 999 is 10 cube, that is 1000 minus 1. Then next will be 10 raised to 4 minus 1. Okay. Like that up to n terms, that is 10 raised to n minus 1. If you multiply by any other number, if you multiply by 5, then this bracket will be 5 plus 55 plus 555 like that. But but it is not possible to convert to GP. 5 here look, 9 is 10 minus 1. Every term we can express as powers of 10. So that will be automatically a GP. Okay. Then the second term is 1 n times or minus 1 n times, that we can add easily. But if you multiply by any other number, this 5, how can we write 5? We can write in different ways, but it is not possible to convert to GP. Okay. If I write 5 as 10 minus 5, then how we write 55? It is 50 plus 5 or 60 minus 5. Okay. So, always you have to keep in your mind divide and multiply by 9. That is the easy way to convert the sequence into GP. Okay. Now, we can write as 8 by 9. The first term, write the first terms together. So, 10 plus 10 square plus 10 cube plus etc. n terms. Okay. Then this minus 1 minus 1 minus 1. Second term write together. How many minus 1? N minus 1. N times. Okay. Minus 1 n times. That put in one bracket and this is in another bracket. n terms. Can I write 10 raised to n? Is it GP? It is GP with first term as 10 and common ratio as 10. So can we get the sum of this first bracket? Sum to n terms of GP. So we can use the formula. So left side here we have Sn and this is a GP. Sum to n terms of GP A into, here the common ratio is R. So we can use the formula R raised to n minus 1 by R minus 1. Okay. So the first bracket is 10 into 10 raised to n minus 1 by 10 minus 1. Then the next is minus 1 plus etc. n times. So we can write as minus n, minus 1 plus minus 1 plus minus 1, minus 1 3 times, that is minus 1 into 3 minus 3. Like that, minus 1 n times means minus 1 into n, that is same as minus n. Now one more step. 10 minus 1 is 9. So 8 by 9 into 10 into 10 raised to n minus 1 by 9 minus n. This much is enough. Okay. So this is the sum to n terms of the given sequence. Now the next one. Find the sum of the products of the corresponding terms of the sequences 2, 4, 8, 16, 32 and 128, 32, 8, 2, 1 by 2. So there are two sequences given. We have to find the sum of the products of the corresponding terms. So first we can write the terms 2, 4, 8, 16, 32. This is the first sequence. There are 5 terms. The next is 128, 32. Write just under this. Then 8, 2 and half. Now the third sequence is obtained by multiplying the corresponding terms. Corresponding terms means first term multiplied to first term, second to second, third to third, like that. So which is the new sequence. The sequence obtained by multiplying the corresponding terms of the given sequences. Is, okay, now you multiply the corresponding terms. 2 into 128, that is 256. Now 4 into 32, that is 8, 1, 2, 128. 8 into 8, 64. Now 16 into 2, 32. And 32 into 1 by 2, 32 by 2 is 16. So this is a new sequence. And what we have to find? Its sum. So sum means we have to add everything. But here we have to use the formula. Don't add directly. Is it GP? 256 into 1 by 2 is 128. 1 by 2 into 1 by 2 is 64. 64 into 1 by 2 is 32. 32 into 1 by 2 is 60. Don't say 256 divided by 2. Okay. For GP it is multiplication. The next term is obtained by multiplying a constant to the preceding term. Okay. So here it is GP with first term as 256 and common ratio R is second term by first term, that is the rule. So it is 1 by 2. Now we can apply the formula. How many terms are here? 5 terms. So sum to 5 terms of this GP. that is A into, the formula is A into 1 minus, here R is smaller than 1, so 1 minus R raised to 5, here N is 5 by 1 minus R. Okay. So it is 256 into 1 minus 1 by 2 raised to 5, that is in one bracket, and 1 minus 1 by 2. Now simplify. So that's equal to 256 into 1 minus 1 by 1 raised to 5 is 1 itself, 2 raised to 5 is 32. Now 1 minus 1 by 2 is 1 by 2. So 256 into 32 minus 1, that is 31 by 32, then taking the reciprocal into 2 by 1. Okay. So 2 and 32 cancel, 16. 16 square is 256. So now you multiply 31 and 16. 1, 3, that is 496. So 496 is the sum of the resultant sequence. The next one, show that the products of the corresponding terms of the sequences AR square up to AR raised to n minus 1, and the second sequence is capital AR square etc. AR raised to n minus 1 form a GP and find the common ratio. So like the previous question, the numbers are given, here it is generally. Sequences are AR square etc. AR raised to n minus 1. This is the first sequence. The second sequence capital AR square etc. AR raised to n minus 1. Now multiply the products of the corresponding terms of the sequences. The products of the corresponding terms. So multiply the corresponding terms. So what is the sequence? The sequence obtained by multiplying the corresponding terms. The corresponding terms of the given sequences. So multiply the corresponding terms. So first one is small a capital A, the next is small a capital A, then into small r capital R, then a into r square, then the next term will be r cube, etc. Small a capital A, r raised to n minus 1, capital R raised to n minus 1. We have to prove that it is a GP. Is it GP? How to check GP? The second term by first term will be equal to third term by second term equal to fourth term by third term, like that. So what is second term by first term? RR by AA, that is RR. Now third term by second term, R square by RR. R cancel, again we get RR. Then A4 by A3, that is also same. R cube by R square. So again we get RR. So it's a GP with the common ratio. What is the common ratio? This R into capital R. So therefore the resultant sequence is a GP with common ratio small r, capital R. So we proved. Okay. The next one, if the pth, qth and rth terms of a GP are A, B and C respectively, then prove that A raised to Q minus R into B raised to R minus P into C raised to P minus Q is 1. So what is given? First we can write that pth term is A. So the notation AP is A and qth term is B and rth term is C. So nth term, what is it? Nth term, general term of a GP, first term into common ratio raised to n minus 1. Okay, AR raised to n minus 1. So here A is already here, small letter. So we can take, let the first term be capital A and common ratio be capital R. Okay. So AP means capital A into common ratio raised to P minus 1, that is equal to small a. Now AQ, that is AR raised to Q minus 1 is B. Now AR raised to R minus 1 is C, small c. Now this we have to prove. For that, take the LHS. Then just substitute. Take the LHS. A raised to Q minus R, B raised to R minus P and C raised to P minus Q is equal to, for this small a you have to substitute AR raised to P minus 1. So A into R raised to P minus 1 the whole raised to Q minus R. Now the next is B. B is AR raised to Q minus 1 the whole raised to R minus P. The next is C. So AR raised to R minus 1 the whole raised to P minus Q. We have to prove that it is equal to 1. So the whole raised to means A raised to Q minus R, then R raised to P minus 1 into Q minus R. Now A raised to R minus P into R raised to Q minus 1 into R minus P. A raised to P minus Q into R raised to R minus 1 into P minus Q. So we have 3 A's, A. Base same means we can add the powers. So A raised to, adding the powers, Q minus R plus R minus P plus P minus Q. So PP cancel, RR cancel, QQ cancel. So we get A raised to 0. Okay. Now the same way you can write R. So base is same, add the powers. So you have to multiply then add. P into Q, PQ minus PR minus Q plus R. Then the second Q into R, that is QR minus PQ minus R plus P. Then the last two brackets, R into P, PR minus QR minus P plus Q. Now PQ, this is plus PQ, we have minus PQ, PR plus PR plus QR minus QR minus Q and plus Q minus P plus P minus R plus R. Everything cancel. So r raised to 0. A raised to 0 means 1, r raised to 0 is 1. So we get 1, that is equal to RHS. Hence proved. Next one. If the first and the nth term of a GP are A and B respectively, and if P is the product of n terms, prove that P square is equal to AB raised to n. So first term is A, and the nth term means the last nth term is B. Now in between we can fill, if the first term is A, it is GP. Okay. So the next term we can write as AR. Okay. Let R be the common ratio. Let R be the common ratio. So first term is A, second term is A into R, next is AR into R, AR square, AR cube, etc. Then here last term is given. So in the question it is like this: 256, 128, 64, 32, 16. Okay. So 256 into 1 by 2 is 128 into 1 by 2. Like that. So when we go from left to right, you have to multiply by 1 by 2. So when we go from 16 to 256, then what is the rule? 16 into 2 is 32. 32 into 2 is 64. 64 into 2 is 128. 128 into 2 is 256. Just opposite. If it is 1 by 2, here it is 2. So here I took the ratio as R, that is from the first term onwards, A into AR, AR square, AR cube, like that. Then the last term is given as B. So what is the just previous term? If nth term is B, then n minus 1th term is B. Here I multiply A into R. So here when we go from this side, then you have to divide. So it is B by R. Okay. So the next will be B by R square, like that. Okay. So let P be the product. It is given as P is the product of these n terms. So P we can write as P, capital P is equal to first term into the second term into third term into fourth term, etc., etc. Since the last term is given, that's why we wrote like this. Otherwise, usually what we write nth term as AR raised to n minus 1. Here the last term, nth term is given as B. So the just previous term, okay, the preceding term is B by R, then here B by R square, like that. Now we again write another P. This P we write from the back. Okay. So P is the product of this. The same P I can write from here. B as the first term. Okay. Then B by R. Just write in opposite way. B by R square, B by R cube, etc., etc. So the last term is A. Just write in opposite order. Okay. So here AR square. Here the first term B, if it is B by R, that is multiplying by 1 by R. Multiplying by 1 by R. So from the last you have to multiply by its reciprocal, that is R. Okay. Now we have to multiply. The question is prove that P square. So multiply. So first one, second one. Just multiply. So P into P. Now here the right hand side how we multiply is multiply the corresponding terms. That's why we write in this order. So it is easy to multiply. Okay. So now you multiply, what we get? A into B, that is AB. put in a bracket. The next is AR into B by R. R and R cancel. Again we get AB. R square cancel. AB. R cube cancel. AB. Etc. etc. Here BA. BA is same as AB. Then again AB. Then again AB. How many ABs here? AB n times. Okay. So if it is, children, if 2 into 2 into 2 into 2, 4 times. So we can write as 2 raised to 4. The same way, AB n times. So we can write as AB the whole raised to n. So P square is equal to AB whole raised to n. That is the question. Okay. So once again, first term is given as A, the last term is B. Last term means nth term. There are n terms. So first we write A, the next term, if the ratio is R, the next term is obtained by multiplying R to the first term. So A, AR square, A, AR square, AR cube, etc. etc. B is the nth term. So the preceding term is B by R. When we go from this side multiplication, this side you have to divide or multiply by 1 by R. So B into 1 by R, the preceding term is B into 1 by R square, like that. Then P means the product of these n terms. So A, AR square into. Now one more P you have to write, that is just opposite order. Start from B. So B into B by R square, etc. etc. The last is A. The preceding term AR, then AR square. Then you have to multiply, then only we get P square. So multiply means the right side we multiply the corresponding terms. Okay. So A into B like that, AB n times. So we get AB raised to n. So one more. Show that the ratio of the sum of first n terms of a GP to the sum of terms from n plus 1 to 2nth term is 1 by R raised to n. So ratio of the sum of first n terms of a GP. So let the first term be, let the first term be A and the common ratio be R. Common ratio be R. So A, AR square, like that. Nth term is AR raised to n minus 1. The sum of first n terms of a GP. So let Sn, okay, let Sn means sum of these n terms. We have already formula for finding the sum. GP sum first term into, we have two formula, either R first or 1 first. Anyone you can use here. Okay. So I am writing R first. So R raised to n minus 1 by R minus 1. We don't know the value of R, that's why we can use either first formula or the second formula. So this is sum to n terms of a GP. Now we have to find the ratio of the sum. So one more sum we have to find, that is sum of terms from n plus 1 to 2nth term. So just we continue here, this is the nth term. Now we have to write n plus 1th term. So how we write n plus 1th term? AR raised to n. Then n plus 2th term, AR raised to n plus 1, etc. etc. up to 2nth term. So 2nth term is AR raised to 2n minus 1. So now for this much terms, sum. Okay. So let Sn dash. Okay, you can use any other notation. So let Sn dash means the sum to n. How many terms from ar raised to n to ar raised to 2n minus 1? That is n plus 1th to 2nth. How many terms are there? How to find the number of terms? Right. Number of terms from n plus 1th to 2nth terms. How to find that, children? 2n minus n plus 1 then plus 1. This is the rule. So 2n minus n minus 1 plus 1. So n. How many terms from 11 to 19? If it is 1 to 19, okay, there are 19 numbers. In between, here 11 to 19, how many numbers are there? Including this 11 to 19. So 11, 12, 13, 14, 15, 16, 17, 18, 19. 9 numbers are there. Normally what we do, 11 to 19 means we just subtract. So we get 8. That is wrong. Including both there are 9 numbers. Like that, if you just subtract 2n minus n plus 1, you will get n minus 1 numbers. That is wrong. You have to add plus 1 also. So that is the rule. 19 minus 11 plus 1. So here also I did the same. 2n minus n plus 1 plus 1. So there are n numbers. Okay. I hope you understood. So here we need number of terms. That's why I found this. So here Sn dash is the sum of the numbers from ar raised to n plus ar raised to n plus 1 plus etc. plus the last term ar raised to 2n minus 1. Ar raised to 2n minus 1. So we know that there are how many terms? There are n terms. So the formula is first term into, what is the first term? Ar raised to n into, okay, r raised to common ratio. What is the common ratio? The same GP we are considering. So r raised to n, the next term is into r, then only we get r raised to n plus 1. So the common ratio is r, but the first term is different. Okay. So r raised to the number of terms also same, it is n minus 1 by r minus 1. Okay. Now we have to find the ratio. What is the ratio? Sn by Sn dash. So a into r raised to n minus 1 by r minus 1. Here we have ar raised to n into r raised to n minus 1 by r minus 1. Okay. Taking the reciprocal, r minus 1 in the numerator. We can cancel this. A cancel. It is 1 by r raised to n. Is it the answer given in the question? Yes, 1 by r raised to n. So understood all of you? First we take the GP ar square up to ar raised to n minus 1. First n terms sum. Sn is equal to the direct formula a into r raised to n minus 1 by r minus 1. Now we have to find sum to n terms. We don't know how many terms are there. Sum of the terms from ar raised to n to ar raised to 2n minus 1. That is n plus 1th term to 2nth term. So how many terms are there? That first we have to find. Subtract n plus 1 from 2n, then you have to add 1 also. So we get n. Then the formula Sn dash, sum formula, first term, here first term is different, ar raised to n, then r raised to n minus 1 by r minus 1, then find the ratio. So we get the answer 1 by r raised to n.